I'm Anil Kumar, and now let us discuss rational functions, which are quotient of polynomial functions. The question here is, write an equation for a rational function with the properties given. We have actually three questions here, and I'll show you how we can find these solutions very quickly, right? First one is an oblique asymptote but no vertical asymptote. It means what? It means the function y should be so that the degree of numerator is 1 higher than degree of denominator. But it says no vertical asymptote. So that means we should have something like x squared plus 1. This will never be 0. That means no vertical asymptote. Do you get my point? Now we need oblique asymptote. That means degree of numerator should be 1 higher. So let me write x cubed here. So that matches. Perfect. This is probably the simplest equation and the correct one. There are many options, so any equation could be right. But the degree of numerator should be higher and denominator should not give you a real 0. That is the idea. B. An oblique asymptote and a vertical asymptote along x equals to 3. So here we do have a vertical asymptote which is along x equals to 3. So x equals to 3 should be 0. So we'll write x minus 3, right? So if I substitute 3 here, I get a 0. That means a vertical asymptote. Oblique asymptote means we are looking for quadratic equation here. I could write x squared plus 2x minus 1, whatever, but I prefer to just write x squared. Simplest form, okay? Next one, an oblique asymptote and a whole at x equals to 3. Now since we have a whole at x equals to 3, that means we have a common factor, right? So x minus 3 is a common factor. Let me write it like this. Is that okay? X minus 3 is a common factor. Now we need an oblique asymptote. So I need to multiply this with something, correct? Something. So that is kind of very important for us. Now the important thing here is if I multiply by, let us say, one factor, then these cancel out and we get that factor. So this is kind of a tricky question. So what I will do here is I will put some factor here also, which is kind of x squared plus 1. This is good to use since it does not add any vertical asymptote, right? Now, and I can write here x cubed. Do you see that? When I write x cubed here, it becomes oblique asymptote, right? So I kind of introduced you to this term earlier, and that is my introduction of whole to the previous solution. I hope you understand that strategy. So this is very critical to understand. So what you understand from here is that if we have no real zeros for the denominator, then there is no vertical asymptote. For a whole, we should have a common factor. For oblique asymptote, we should have degree of numerator 1 higher than that of the denominator, right? With this in mind, you should be in a position to write equations where oblique asymptote is being discussed. Thank you.